Hello, this is JF from Bod Factory again. Sorry for the slight delay. We've had some small issues. Now we're actually back up on live. You may or may not be coming in from the wrong. Turns out when you stop a stream, you actually end it. You can't restart it again. So I had to create a new one basically immediately as well. So this is the correct webinar. If there's anyone out there, say hello. Hopefully you can actually hear me, and we can go from there. I'll just do a voice check. Okay, good.
Now we're actually back.
So I'm going to be showing you basically how to cut a PCB board that's been printed with Squink and then we're going to actually plate holes and solder to them. This has been something we've been working on for a while now. Due to popular demand, a substantial number of people have been asking us not only how you can sort of put a through-hole component or place a wire, but how you could solder to it. And that is a technical challenge that all people in the inkjet printing or any dispensing business, dispensing conductive materials, are dealing with, because solder flux as well as the heat can have an impact on the trace's ability to stay to the substrate. It just really boils down to having enough bulk silver on the substrate. Long story short, we've come up with a pretty fair solution that seems to resolve this issue. It allows you to essentially solder to components to your traces. So what I have here right now is the shears. We have a pair of 8-inch shears, and I'm going to be cutting up this guy that we made last week, and we're going to go through sort of just step by step essentially the processes required and a few tips and tricks for using these tools. You can now buy these shears and the rivet press, which you can see sort of hanging back right here, online for on our website now. So we just put them up. This guy goes for, I believe, 600 or 700, and the shears, 8-inch shears at least, these are the 8-inch shears, go for 300. The whole set actually goes for anywhere from 1,000 to 1,200 for everything, including the tool head and the 30 mil rivets. And with these tools, you can essentially shape your board so you can cut it down to size after you print it, and plate and solder to it. So these are the wires that I landed with. Don't mind this. So I'm printing a circuit right now. You may have heard it in the background. So first off, we're going to go through the process of actually cutting the board. So this aside, bring this into focus. So 8-inch shears are a bit different from, say, cutting with paper. These are much more durable. The other technical term I've heard for these types of shears are also known as guillotines, which is sort of harkens back to the French Revolutionary era. But they are essentially orb cutters, another word for them. But they consist of essentially hardened steel right here and a cutting blade right here. And the blades themselves are not like terribly sharp. It's really all about having just material with a hard enough edge that it essentially breaks off the FR4. FR4 is a fiberglass. It's difficult to cut. It's difficult to cut with scissors. Difficult to sort of saw with an ordinary knife. So having a pair of shears like this is really useful. When we got one of these, there was a little bit of like, do we really need this? I can tell you, really valuable. It's allowed us to just simply chop up a board after we were done with it. Critically, it doesn't seem to flex the substrate so much that it breaks it. And that's kind of critical. So I'm just going to go through the process right here. And I'm just going to do this so you can see everything. 1 second. So Basically, it goes like this. I've done the board, some wires on it already, but that shouldn't get in the way of anything I'm trying to do right now. So, let me just adjust the camera just a little bit so we can see what's going on. Okay. So, lining up the board with the edge is kind of critical if you want to get really close to your print outline edge. Typically, if you cut this board already and you have a sort of straight edge that you're happy with, you can just essentially force the board along that edge, keeping in mind that these components are already on there. So you have to be kind of careful. I'm just going to essentially line up the board with the bottom cutting edge so that I can get a straight enough cut, instead of lining it along this edge right here. There's a safety latch on top of this, so you have to bring it down a little bit to disengage the latch. And I've discovered a problem. Seems like I'm unable to actually get past this guy because of this cap right here. So I'm going to have to cut it in this manner so that the cap does not get in the way. There we go. No problem. Looks like a nice cut, I'd say. So keeping that in mind, that this guy can sometimes get in the way of your caps. Luckily there's no dentation. I just noticed that before cutting it, before cutting all the way through. Just want to continue along here and just, do a little spot check to make sure that you're not going to be hitting any of these components. By the way, it's quite possible to actually print the board and then reprint the outline and then realign the board for dispensing and pick in place after you cut it. That's completely possible. You just have to take a look at our tutorial page and look at the PNP pick and place tutorial to explain how to do that. There we go. Do I look like a professional board or what? The thing I like about it the most is that the components are completely fine. They're still attached to the board. We were finding when we were using scissors that it flex the board too much. And then of course knife, even cutting with a sharp knife, it's just painful, to say the least. Okay, so we've cut the board. Now we're going to get to the next step of the whole process, which is blading. So, people ask us, how do you actually build circuit boards without having any drilling? There is no drilling on our machine. We do an additive manufacturing method to make the vias and so forth. You print conductive traces, leave gaps open in the insulating layer, and then you print on top of that. And essentially where they are exposed, bottom and top, they connect. So for drilling, you actually have to have a drill press. You need to make the holes, and then you need to place the rivets and press them into the hole. So I am using a ordinary Dremel, it's a 4000 with the tool press. If you go to our blog, or rather a tutorial page, we mention which model and type we use. We have also gotten some tips, some drill bits rather, from Amazon as well. And these are sized appropriately for the hole we want to actually drill out. So, any questions right now? No one's asking any questions? Okay, good. So long story short, there's a manual on our tutorial page that explains what kind of design guidelines you want to do when it comes to making a via. You know what? Why don't we talk a little bit about that first? So you need to give me 1 second. I'm going to resize this, and I'm going to add a window of one of our designs. 1 second, please. Okay, so This is the footprint editor for one of our components, or sorry, one of the connection points on this board. Okay, and specifically where I've actually wired it up. I want to sort of explain what I did when I designed this board in terms of making sure that the vias, the plated through holes, were sized correctly. So I wanted to use these 30 mil or 0.8 millimeter rivets that are supplied with every single one of them. It can be smaller or larger depending, but we found that we have the best results for 30 mil rivets. They're small enough, but they're not too small you can't handle them. And they work well with 100 mil headers, so I consider them to be the standards. Long story short, when this was designed, I'm not sure if you can see that page. I'm not going to add another window. Hold on a second. Pad properties. Okay. So I'm looking at the pad properties of this footprint for this through-hole component, and you can see that I've sized the annular ring, or basically the hole diameter of the pad, is 0.8 millimeters. And if you take a look at the tool manual for 0.8 millimeter or 30 mil rivets, it has a head diameter of 1.6 millimeters. So I have more than enough pad or annular ring for the material for the rivet to connect. The hole is going to be 1.1 millimeters. You could have spec'd 1 or 0.9, but 1.1 is more than enough. And when Squink takes your drill file for printing the insulating layer, it's going to look at that drill size, 1.1 millimeters. It's going to be a slight expansion coefficient to deal with ink spreading. But generally speaking, 1.1 millimeters is what you can expect in terms of a total exposed pad. And the drill bit I have here, you can see right here, is 1 millimeter. So I'm going to have more than enough exposed silver pad for the top of the head to connect with the rivet, or sorry, the rivet to connect with the trace. Regardless of what direction or thinness of the trace, I just need to have a little bit of exposed silver on top. But following the design guidelines in that respect, check the manual that we include with everything. Take a look at what the actual head diameter is. Make sure the pad is at least that. Make sure that the spec drill size on the tool press manual is essentially sized a little larger than the actual diameter of the hole with the rivets, and that should be fine. We've designed a lot of boards already, basically following these specs, and it seems to work fine. So I am going to start drilling these holes out. And I've built this board before, and I want to make sure that I don't touch any of these components. That would suck if I hit any of these guys. This drill bit is going to be running around 20,000 RPM. Keep in mind that you can essentially do this process in one step or another. You can do it after you've built the whole board, done everything. That's totally fine. This is what I did here. Another option is that you essentially print the board, take it off the platen, cut it, put it back on, cut it, drill it, put it back on. That's possible. I've done that before. You just have to reprint the edges of the board to make sure that it's aligned properly. But in this case, when I was designing this board, I made sure that there was more than enough area for this drill bit to fly around and not touch any of these components. So that's another thing you have to keep in mind when you're designing. So I'm going to put on some PPE, personal protective equipment. No sleeves to get caught in anything. I highly recommend that you do such the same. If you've ever had a bit break off, for very thin vias, that's a problem. For these bigger drill bits, I haven't seen any issues, but I highly recommend it. If you're doing a lot of drilling with FR4, I mean, 4 holes isn't a big deal. 20, maybe 100 holes, you might want to consider some ventilation or masks. One thing I learned is that FR4 is actually, the fiberglass particles are not terribly safe. That's one thing we learned, at least early on, about drilling. And I think that's really interesting. Not a lot of people know about that. People often come to us and say, why don't you just do milling? Milling is really interesting. It's definitely, it might work for you. But you have to have a heck of a lot of ventilation if you're going to be doing much of it, because that FR4 can actually get into your lungs and cause some serious damage. Fiberglass is not something to be joked about. So for 4 holes, not a big deal. For a lot of them, you should get a mask. So, looks good. Not sure how well you can see that. In fact, can you at all? Yeah, you can see the holes. So those are the holes. Not too bad. I got them almost exactly center on. And yeah, this is definitely something I can use. I mean, in this case, the expansion was, pad size are pretty big. The expansion hole is a little bit bigger, so I have more than enough space for the header to attach. In closer areas, you can, of course, go smaller, but it's always good to be safe. So, because basically the problem is that you're using not a CNC machine to drill nuts, although you can, but simple drill press. Alright, so the next step is opening up. Let me close all these windows first. Why don't we do that? Okay, so let's begin. We're going to push this away and bring in our lovely drill press. So, what I have here is our PCB rivets. They're about, I think, 1,000 in each container. So they cost $50 online. So pennies per rivet. Typically, what I do is I use what we supply each machine with. I use a syringe with a tip, the pink tips on there, and I use them to hold the rivets or pick them out of the container. Keep in mind that might not work for all of your components, but for 30 mils it works great. Because placing these rivets into the hole is not, it's probably the most irritating part of the process. But long story short, what we're going to be doing is we're going to be placing these components, these rivets, into the hole, and then we're going to use this tool press to essentially fill in the hole, sort of hold it there, and then against the bottom anvil, press the material to the bottom. So the if this is your substrate, and you've drilled through, so if this is your substrate, you drill the hole through, you place the rivet, and essentially there's the bottom part sticking out. That is going to be compress fitted onto it. So essentially you get a ring that is gripping on both sides of the substrate and compressing onto the conductive silver traces. So I take my handy syringe with a rivet on it and essentially place it into the hole. Should fit right in there. And you can see, I'm not sure you can see very well, but essentially the rivet is sticking out right here. I'll just do this one at a time. So the way I do it, there's different ways of doing this, but the way I do it is I hold the board up against the hammer. There's basically two parts. There's the tool head, which is like the hammer, and the anvil, which is what it's going to be pressed against. The hammer is going to be pressing the rivet against. The cool thing about this anvil is it's got a small, what I would call a pin that's spring-loaded. You can adjust the amount of spring tension by pulling it out and altering it using a simple hex wrench. That allows you to kind of control how much spring back you're going to get when you press down. Why does this pin sit there? Well, the problem with any kind of compressed fitting of rivets is that you have to make sure that the space within the hole, essentially, there's no kinking. The copper is not going to be forced into the hole. You want to make sure that hole is going to be open. You want to make sure that the tube essentially is forced outward this way. So you need to actually have the hammer go into the hole and essentially keep on going in. You don't necessarily need a spring in there, but it's very useful for pushing out the hammer after you've compress fitted the rivet. If you get one, you'll see exactly what we're doing. You'll understand exactly what I'm saying. I think the tool manual does a really good job of explaining it in written. So check it out if you haven't seen it yet. It's on our tutorials page. So place a little force, compress it on, and there we go. Let's see if I can. Maybe this camera's better. So there we go. That's the other side of the board, and you can see that the anvil has essentially forced the copper out onto the bottom edges. And the copper is completely connected to the conductive silver. So let's pick up the pace. Let's do all the rest of these guys. Usually I can stick about maybe 3 on here at a time. You can also try it from the bottom, like going up. That's doable. I haven't fully validated it. I don't see why you can't. Okay. Do all these again. Holding the board against the hammer, pressing down. You don't have to use a lot of force. You don't have to, sit on the handle. You want to make sure that the pin is also going into the rivet hole from the bottom as well. If it doesn't, it will break the pin, and then you have to get that replaced. Perfect. These look great. So, now we're done. Now we can go to the next step, which is soldering. Okay, so alright, let's just unbig this page. Okay, so this is my soldering iron. And solder wires. Let's get this all the way over here so you can see everything. I think they need more cameras. Okay, so let's turn on the soldering station. It's running at, I think, 365. Yeah, that's too high. I've been saying 315 is perfectly good. You can go a little higher, but I seem to get the job done quite nicely with 315 Celsius. Not maybe from maybe a U.S. company, but we like to stick to standard units. Just want to check in. Am I being heard correctly? Okay, good. Okay, so let's get this process started. So I got some solder here. Got these wires. Now we'll just heat it up. Good. There's one. And there's wire number 2. Okay. Let's display them a little bit so that I can avoid any bridging. So we recommend that you solder from the back side. We recommend that you solder from the back side. Best protects the solder, the conductive ink, from the heat. And that you apply essentially a little bit of solder onto your iron. And there you go. There's one. There's 2. Yes. These are connected and no damage whatsoever to the traces. There you have it. That's how you solder to a screen printed board. What I recommend for every user that wants to consider getting this is they get the full set. As I said before, cutting these boards, having a shear, really useful to have. The rivet press, you need to have a drill press or some sort of CNC manner for drilling out. We don't provide that. Typically, almost every space we've sold a machine to has a drill press. Otherwise, you can get them online for not very much, $150. Even less. So, long story short, do you want to solder to boards? Do you want to get through whole components? Do you want to place headers? Do you want mechanical strength? Do you want to actually be able to solder and desolder wires? Although we haven't actually fully done a cycle test on that, but I have replaced wires before once. You should get this. You should get these tools. We're going to be releasing sort of more examples of certain things we've done, like we've connected headers and things of that nature. We've also connected components. Wires are basically the most simple one. Yeah. We've also done this with paste. I have taken paste and used the heat gun to that. I mean, it's kind of a roundabout way of doing it, but it works as well. Any kind of solder paste seems to work. Lower temperature the better, obviously. But there you go. Solder to your boards. This is JF. I'm signing off. Thank you very much. We'll talk to you soon. If you have any questions, by the way, contact us at botfactory.co, either through our website or emailing us at contact@botfactory.co. If you have any other questions where you have your own tools already, like your river press or your shears, and you have questions or problems, you can contact us at support@botfactory.co as well. Thanks. You guys have a good evening.